show you how to estimate a regression line by hand. So what I'm going to do is I'm going to put my data into Desmos here, and I have a nice scatter plot of this data. You can do this on a sheet of paper too, but you have to have your data plotted really well on a nice sheet of graph paper, and you could use spaghetti to help you find the line. But I'm going to show you how to do it taking a screenshot from Desmos in Google so that you can use this tool to help you. So what I'm going to do is I'm going to come in here to Desmos, and I'm going to take a screenshot of this data. Okay? And when I take the screenshot, I want to make sure that I can see both the X and the Y axis in my screenshot. So you can see the X axis and the Y axis. And then I'm going to come into a Google Doc. Okay? And you can open a new Google Doc, but I'm going to use this Google Doc that I have here. So you open a new Google Doc, and what you want to do is you want to insert a drawing into this Google Doc. So when you get to you open your new Google Doc, and you're going to go Insert Drawing, New. And once your drawing pops up, you're going to insert an image into it. And the reason you want to insert the image into a drawing instead of just in the Google Doc is this will let you put a line on the scatter plot. So I'm going to choose an image here. So this looks like the screenshot that I just took. Okay. So this is the screenshot that I just took from Desmos. And so what I'm going to do is I'm going to eye a line that I think will best fit this data. And when you draw this line of best fit, you kind of want to try and have as many points above the line as below the line. Because remember, not every single one of these points is going to fall on the line of best fit. Some of them might fall on the line of best fit, but not every single point is going to do that. So to do that, if you look right here over in Desmos, there's this little drop-down menu, and the first thing says line. So I want to go to line. Okay. And I'm going to go to the top of my graph here, and I want to insert a line that I think is a good line of best fit. Now, if I do not, so I'm looking at this line, and it looks to me like I think that would be a pretty good line of best fit. If I don't like it, I can choose this arrow here, and I can move it a little bit up or down and adjust it. Okay. So if I'm looking at this line here, I think this line is a pretty good fit. I have, might move it over just a little bit more. I'm just kind of eyeballing it. Find a line that I think would be a good fit for this data. Okay, so you want about as many points above the line as you have below the line. And it looks like I have that here. So I think that's a good fit for the data. So then you want to pick 2 points that are on this line and use those 2 points to help you estimate a line of best fit. So when you choose the 2 points that are on this line of best fit that you've estimated by eye, they don't have to be points from the scatter plot. They just have to be points on the line. So in general, I try and pick points on the line that are easy to get the coordinates of. So for example, this point. Now this happens to be a point that's also on the scatter plot, but it doesn't have to be a point that's on the scatter plot. But that point is easy to find the coordinates of, 4, 4. And this point, it looks like it goes through this point too, and that's a point that's also pretty easy to find the coordinates of, 6, -1, okay, from my scatter plot here. Now again, let me reiterate the fact, these 2 points happen to be points from the scatter plot, but they don't have to be. You could have used this point and said, okay, I think this point. So I could have used this point and this point, or this point and this point, and found the coordinates of that point. I think the coordinates of that point would be like 1.5, 10, okay, for example. But you're going to pick 2 points off this line that you've eyeballed by hand. So the 2 points that I picked to use were 4, 4, and 6, -1 in this case. So I'm going to write those points down so I have them. So 4, 4, and 6, -1. I'll make these bigger so that you can see them. So when I was talking about the spaghetti earlier, when we were drawing this line, that's where you would use a piece of spaghetti and put it, if you were doing it by hand and you had a graph on a piece of graph paper by hand, you would use the spaghetti and kind of move it to eyeball what you think the line of best fit would be. Now, in order to estimate this line, there's some formulas that will be useful to you that you've used in the past. And I'm just going to remind you of them. So the first, this is the slope-intercept form of a line. Okay. Y equals mx plus b. Remembering m is the slope and b is the y-intercept. The point-slope form, it allows you to find the equation of the line if you have a slope and one point. And finally, the equation for the slope, remember it's rise over run. So y2 minus y1 over x2 minus x1. So the first thing that I'm going to do is I'm going to use my points here. And I'm going to calculate the slope. So remember the slope is y2 minus y1 over x2 minus x1. Now it doesn't really matter which point you call the first point, which point you call the second point. Just remember each data point has an x and a y. So if I put this point first when I'm trying to find my slope, then this would be x1, y1 because it's the x coordinate of the first point would be 6. The y coordinate of the first point would be -1. And this would be x2, y2 because the x coordinate of the second point is 4 and the y coordinate of the second point is also 4. So to calculate the slope, in this case, I would just use this formula and I would have y2, so in this case, the y coordinate of my second point is 4, minus y1. So be careful because y1 in this case is -1. So it'd be 4 minus a -1. And in the denominator, x2, so the x coordinate of the second point is also 4, minus x1, the x coordinate of the first point is 6. So if I calculate that out, four minus a -1 is a +5, and 4 minus 6 is -2. So that would be -5/2, or you could write that as -2.5. So now I need to, that's the slope. So now if I want to estimate the equation of my line of best fit. So I eyeballed my line, I picked 2 points off the line, I found the slope using the slope formula. Now I'm going to use this point slope form, and you need one of the points for the point slope form, because you're going to plug in x1, y1. So let me remind you, here is the point slope form again of a line. Y minus y1 equals m times x minus x1. And I can use my first point, this was x1 and y1, and plug in those values. So in this case, I would have y, not you, y minus y1. So the y coordinate of the first point is -1, so be careful because you're subtracting a -1 there, equals m. So m is my slope. I already found my slope just a few minutes ago, so -2.5 times x minus x1, which in this case is 6. So the last thing that I want to do here is rewrite this equation so that it is in slope-intercept form. So in order to do that, slope-intercept form is y equals mx plus b. So all I'm going to do is just use the distributive property here and add this value over. So I'll show you that. So in this case, just so we get started in the same place, y minus a -1 is really y plus 1 equals, so this would be -2.5x, and then when I take -2.5 times -6, a negative times a negative is a positive, and that would give me plus 15, and then to get this in slope-intercept form, all I need to do is subtract the 1 over here. So I would get y equals negative 2.5x. And when I take the minus 1 to this other side, I get plus 14. So this is an estimate of the line of best fit that I got using my scatter plot and eyeballing the line. So right now I'm going to go back to Desmos, and I'm going to write, or actually find the regression line. So y1 is approximately, ax1 plus b. And if you notice here, okay, it says in this case, my A is negative 2.61017, and my B is 14.4746. So that equation would be y equals negative 2.61x plus 14.5b. And if you look at the equation that I got when I eyeballed it, it was negative 2.5x plus 14. So that's pretty close. So that is how you estimate the line of best fit by hand.